Assalamu alaikum students. Your first chapter, that is of stoichiometry, is complete. Now we will go for the solution to the exercise questions. Okay. Today's objective is exercise, that is MCQs and short question answers given in question 1 and question 2. They will be solved. Now first we will go to the MCQs, multiple choice questions. You people open your book along with and try to solve them. Okay. The number of molecules present in 1 mole of water, that is 6.02 and square 23. Very simple answer is this one. Class contains 500 cm3 SO2 at STP. The class contains, the correct option is 1.427. How we get it? This one is relate molar volume, that is 22.414, with the mass of the 1 mole of this substance, that is of SO2. The mass of 1 mole is 64 grams. Convert 500 centimeter cubes into decimeter cube by dividing it with 1000. So relate them. It will be 64 upon 22.414 multiplied by 500. So the answer will be 1.427. The next one is a necklace with the 6 grams of diamond in it. What is the number of atoms in it? As you know, 1 mole of carbon is equal to 6.0 10 by 23 atoms in it. So 6 gram will hold, make up the ratio. So you will get there, that is a 6.0 10 by 23 divided by 12 multiplied by 6. The answer will be 3.01. The next one is, what is the mass of aluminium in 204 grams of aluminium oxide, Al2O3. Take out the mass of Al2O3 first and find the mass of aluminium in it. The mass of Al2O3 is 102, while the mass of aluminium in it is 27 multiplied by 2, that is 54 grams. You will say 1042 grams hold if that is 54 grams of aluminium, so 204 grams will hold. How much? The answer comes out as 108 grams. This is what one says. Right? The next one is that what is the mass of the reactant which is consumed earlier and gives lesser quantity of product? That is quite easy, you know very well. It will be termed as the limiting reactant. The next one is, which one of the following compounds contains the highest percentage by mass of nitrogen? So for the each molecule individually calculated, you will find that it is N2H4 which holds the maximum. Now it's up to you that how to calculate it. N2H4 is also termed as hydrazine. This will be the answer. How did you get it? You have to take it out. Now the next one is, vitamin A has a molecular formula C20H30O. You have to calculate the number of molecules in 500 milligrams of vitamin A. Now find out first the molecular mass of this vitamin A, then convert milligrams into gram, and then now relate it. We say by means of the formula, that is number of molecules is equal to given mass or molar mass multiplied by Avogadro's number. Avogadro's number is 6.0 10 by 23. The molar mass is what we will calculate. The milligrams that you got, that will be 0.5. So calculate it, you will get your answer, and the answer is 1.05 into 10 to the power 23. You can calculate it, right? Now the next one is, when 1 mole of each of the following is completely burned in oxygen, which will give the largest number, largest mass of carbon dioxide. Here, 4 substances are given. React carbon monoxide with oxygen. You don't have to give the more than 1 mole, but you just have to take 1 mole of, or 1 molecule of carbon monoxide, right? The equation will be carbon monoxide reacts with that of half O2. 1 oxygen is required to convert into carbon dioxide, right? Diamond made up of carbon. Carbon reacts with O2 to produce carbon dioxide. इसमें भी 1 mole produce किया, इसमें भी 1 mole produce किया. Ethane, it is carrying formula C2H6. When it is burnt in air, it burns in this ratio. It produces that of 2 carbon dioxide and 3 water molecules. Here, this one, right? Now the next one is there. The methane then burns in air. It produces 1 mole of carbon dioxide and the 2 moles of water, right? So what will you get? You will get the answer is ethane, as it has produced a maximum number of carbon dioxide. Go right. So the answer is option C. The next one is 1 mole of the ethanol and 1 mole of ethane has an equal what? Each of them are 1 mole. So 1 mole means whatever the mass they will carry. So will be equal to 6.0 times per 23 molecules, as they both are the opposite compounds. So the answer D is correct. They don't have same mass, they don't have same number of atoms in them, they don't have number of electrons in them that is equal, but they have the number of molecules equal. Methane reacts with steam to form hydrogen and carbon monoxide, as it is given, that is CH4. 1 mole reacts with water to produce 1 mole of carbon dioxide and 3 moles of H2. It's saying what volume of H2 can be obtained from 100 centimeter cube of methane at the standard. You can see here there is 1 is to 3 is the ratio. So if 100 centimeter cube of methane is there, so 300 centimeter cube of the H2 will be produced in simple, right? The Avogadro's number constant is the number of what? Atoms in 1 gram of helium. 1 gram of helium. Yes, the Avogadro's constant is the number of atoms in 1 gram of helium. Helium exists as monatomic element, right? No, not of 1 gram. Helium is carrying mass 2 grams. So it will be, no, it carries the volume that is, yes, it is 2 grams, right? तो फिर इसके पास जो है नंबर ऑफ एटम्स सेम तो ना हो. Molecules in 35.59 grams of 5 grams of chlorine. Chloride. Chloride is the ion, right? So not the number of molecules are there. 35.59 grams. तो ये नहीं आपके पास में, ये भी गलत हो जाएगा. Electrons needed to deposit 24 grams of magnesium. No. And the last one is atoms in 24 grams of magnesium. Yes, it is correct. The mass of one atom of magnesium is 24 grams. Once again, atoms in 1 gram of helium, that is wrong, because the molar mass of helium is 2, right? While the molecules, that is also wrong. Electrons, they are needed for the 24 gram of Mg, that is also wrong. And the correct one is option D, that is 24 grams of magnesium. The next one is how many moles of oxygen are needed for the complete combustion of 2 moles of glucose. Now, 1 mole of C4H10 when burned in air, it needs how many oxygen? The answer is 13. For this, you have to write a balanced chemical equation. This balanced chemical equation, according to this, you have to write like this: C4H10 reacts with oxygen to produce 4 moles of carbon dioxide and 5 moles of water. Right, here the total number of oxygen on product side, that is 13, so it needs 13 by 2 oxygen molecules, that is 13 atoms of oxygen are needed here. This one will be your answer. The next one is if 4 moles of SO2 are oxidized to SO3, how many moles of oxygen molecules are required? Once again, write the equation for this. A balanced chemical equation is given. 2SO2 reacts with O2 to give 2SO3. For this, you will come to know that 1 mole is required by the 2 moles of SO2, so the double, or the 4SO2 will require 2 moles of the O2. This will be your answer. Right here, once again, we have the next one. The relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine gas? It is 142 grams, as 1 mole of chlorine gas holds 71 grams. That 35.5 into 2, because chlorine gas is Cl2, right? Then the next one is there. It is 142 grams multiplied by 2 for the 2 moles. Which of the following statement is incorrect? That is number 15. Number 1, 12 grams of fluorocarbon gas contains 1 mole of atoms, which is correct. 28 grams of nitrogen gas contains 1 mole of molecules of N2, it is also correct. Right? 1 DN cube of 1 mole DN cube solution of NaCl contains 1 mole of fluoride ion, which is also correct. And then what is wrong in it? Your answer will be none of these. All are correct, right? So the answer is none of these, right? Ji? Now the next one is 1 mole of propane has the same what? 1 mole of propane has the same number 1 number of hydrogen atom as in 1 mole of methane. Methane के साथ compare करें propane to propane carry 3 carbons in it. The formula mass the formula is CpH8 while methane अब इनको दोनों को compare करें the hydrogen atom is different same methane. Number of carbon atoms as in 1 mole of butane, no, that is also not same. Butane में 4 carbon है जबकि propane में there are 3 carbons. Mass of half a mole of hexane, half a mole of hexane C6H14 है और वो है C3H8, तो 8 का half 14 तो नहीं होता, ये भी गलत हो गया. Number of molecules as in 1 mole of methane, ये भी 1 mole कह रहा है, वो भी 1 mole है, so it is correct. The correct one is the last one, that is ethane. Now the next one is what is the mass of 1 mole of iodine molecule? Iodine exists as I2. The mass will comes out as it is given. That is 127 multiplied by 2. What will be the answer? Calculate it. It will be 254. It will be 254. This will be the answer. Now the next one is that is what volume of SO2 at room temperature and pressure is produced on heating 9.7 grams of zinc sulfide. If reaction takes place as follows, you can see here 2 moles of zinc sulfide react with 3 moles of O2 to produce 2 moles of zinc oxide and 2 moles of SO2. The question, according to the question, we say volume that is asked 1.2 dm cube 3.6, 2.4 or 4.8. Now what will be the answer? Now you can see convert the 9.7 into moles. The molar mass of zinc sulfide is 97. Zinc is 65 plus sulfur 32. Calculated, it will comes out as 0.1 mole. If you take it from the equation, it will give you 2:2 ratio between zinc sulfide and SO2. 0.1 will be equivalent to 0.1. So 1 mole of SO2 holds 22.414. So 0.1 will hold how much? 22.414 divided by 1 multiplied by 0.1. The answer is 2.4 dm cube. The answer is 2.4 dm cube. Right, G, this will be your answer. Right, this is all about the MCQ, short questions which are answered. Next one, the first one is answer the following questions briefly. That is 58.5 AMU are termed as the formula mass and not the molecular mass of NaCl. Why? The answer is NaCl is an ionic compound and ionic compounds are formed of aggregates of ions. The mass of the NaCl is 58.5. It is a correct statement. You have to give a reasoning that why, you have to justify that why this statement is being true. ये बिल्कुल एग्जैक्ट क्यों है, इसको आपने जस्टिफाई करना है by your answer, right? Ionic compounds are mentioned only by their formula units, and the formula units when given in grams, you will say them as their formula masses. So this is not a molecule. As I told you, they are the aggregates of ion as they are the ionic compounds, so you cannot give them as the molecules, right? So it is the correct statement that 58.5 AMU is termed as a formula mass but not the molecular mass, and ionic compound cannot be given by their molecular formulas. They are only given by their formula units or the formula or chemical formulas only, right? Or formula units, right? Now the next one is concept of limiting reactant is not applicable to the reversible reactants. Explain once again. Here, as I told you earlier, last time हमने एक example की थी that nitrogen and hydrogen when react together they produce NH3. This is a reversible reaction. मैंने आपको कल भी बताया था. I'm telling you again that whenever there is a reversible reaction, we say reaction never goes to completion. और product हमें मिलता है by the end of the when reaction is finished. उसके बाद जो हमें मिलता है that is product. ठीक है, तो आपके पास में यहाँ पे लिमिटिंग रिएक्टेंट अप्लाई नहीं हो रहा. वेन एवर देर इज फॉर्मेशन ऑफ प्रोडक्ट, कुछ क्वांटिटी प्रोडक्ट का बन जाएगा, रिएक्शन विल be backward direction, will be in backward direction further then, right? Because the equilibrium will be disturbed. Such reactions which are reversible reaction, in them there is establishment of an equilibrium between reactant and the product. So that's why limiting reactant concept is not being applicable. The next one is how many covalent bonds are present in 9 grams of water. Now convert first of all 9 grams into its what will you say, moles. What will you get? Now apply the formula here, that is number of molecules is equal to given mass of water over molar mass of water multiplied by Avogadro's. Place 9 above as a numerator. Molar mass of water is 18 multiplied by 6.0 times by 23. The answer is 3.01 into 10 power 23 molecules. Now here in water molecule there are present two covalent bonds. Here you can see between oxygen and hydrogen, right? There are present two covalent bonds. So multiply this number of covalent bonds with 3.01 plus 523. You will get your desired answer. That is 6.0 plus 523 covalent bonds. Right? The next question given is differentiate between that of limiting and non-limiting reactant. I hope you can understand it well now. Limiting reactant is the reactant which is consumed completely or it gives the lowest number of moles of the product. Is it? Do you remember? It gives you the least number of the product, right? It is to be completely consumed in the chemical reaction, right? Now the whole reaction depends upon the quantity of the limiting reactant, that how much it is being taken, what amount is being of this taken. And what about the non-limiting reactant? Reaction is not dependent upon it. It will always be in the excessive amount, right? The formation of the amount of the product, that is yield, is not going to depend upon the non-limiting reactant, but it depends upon that of the limiting reactant. The next question is how many molecules of water are there in 12 gram of ice? Is there any difference between ice and water? No. The only difference is the change of state. Otherwise 12 gram of ice is also water. So once again apply the same formula, that is number of molecules is equal to mole mass, given mass over molar mass over multiplied by Avogadro's number. You will get your desired answer. Quite simple in this question. Now come to the next one question, or the next one question, that is also a short question. 1 mole of sulfuric acid should completely react with 2 moles of sodium hydroxide. How does Avogadro's number help to explain it? Now for this you must have to write a complete balanced equation between sulfuric acid and sodium hydroxide. It is given 2 NaOH reacts with 1 mole of sulfuric acid to give you 1 mole of Na2SO4, that is sodium sulfate, and 2 moles of water. It is very clear. You can express it in the form of moles. You can also express it in the form of Avogadro's number. Now read it by means of the, you will say 2 formula units of NaOH, as it is also ionic compound, reacts with 1 mole, 1 molecule of sulfuric acid. No, 1 molecule of sulfuric acid produces 1 formula unit of Na2SO4 and 2 molecules of water. Now in terms of moles, you will write it as 2 moles of NaOH reacts with 1 mole of sulfuric acid to produce 1 mole of Na2SO4 and 2 moles of water. Now, how will you read it with respect to the Avogadro's number? It is quite simple. 2 multiplied by 6.0 times by 23 molecules of NaOH, 2 multiplied by 10 power 6.0 test by 23. Uh, Formula units of NaOH reacts with 6.02 test by 23 molecules of sulfuric acid to produce 1 into 6.0 tens power 23 formula units of sodium sulfate and 2 multiplied by 6.0 tens power 23 molecules of water. So this is how Avogadro's number helped to explain the reaction between sulfuric acid and sodium hydroxide. The next one is give reason that 1 mole of different compounds have different masses. It is very simple. It is taken from the theory that is given behind. You can see here explained by means of the example that 1 mole of water, what the mass it carry, 18 grams. The number of molecules in it will be 623 particles. Similarly, 1 mole of carbon dioxide, that is having mass 44 grams. Again, the number of molecules in it are same. If you take the example of NaCl, what do you think about? NaCl is the formula unit. When one formula unit is taken, having mass how much? 58.5 grams. It is equal to 6.0 10 per 23 particles once again. Okay, so this is how we say 1 mole of different substances having different masses in it. Right? Now, every time you have to remember that 1 mole means 1 unit of that substance, whatever, whether it is a molecule or a formula unit, an ion or whatever. Okay. Now, next one is 23 grams of sodium and 23 grams of uranium have equal number of atoms in them. Yes, it is correct. How? Just take a look. It is same just like the above question. 1 mole of sodium having mass 23 grams. 1 mole of uranium having mass 238 grams. Both are 1 atoms. Okay, so what do you think about? 23 grams of sodium is equal to 1 mole is equal to 6.02 in 10 power 23 particles. Same is here for uranium, but the mass is different. The 238 grams of uranium is equal to 1 mole is equal to 6.0 10 power 23 atoms. Okay, the next question you have done it already as it was given to you in your quick quiz or the some questions or the homework in the previous one lectures. Now here, the next question is, the question is quite easy, you can do it yourself. Okay, now calculate the weight of oxygen gas evolved and 5 grams of potassium chlorate are completely decomposed. 5 grams. Calculate the weight of oxygen gas evolved. To this, you must have to write the balanced chemical equation first as it is given. 2 KClO3 produces 2 KCl plus 3O2. You have to relate KClO3 with that of oxygen. Yeah. Now, according to this equation, 2 moles of KClO3 produces 3 moles of O2. Now, convert this 5 grams into moles once again. For this, you have to calculate the molar mass of KClO3, which is being calculated here as 122.5 grams. Now, relate it. Make a conversion factor. According to the balance chemical, this is your conversion factor. That is 2 moles of KCl3 is equal to 3 moles of O2. The conversion factor is 3 upon 2 moles of O2. The moles we got by means of the 5 grams, that is 0.04 as calculated above. So multiplied with this value, you will get your answer. It is, that is 32 grams of oxygen, right? Is the molar mass of this one substance. The moles you got from this numerical, that is 0.06. To get in grams, multiply it with the molar mass of the oxygen gas. Multiply with 32, you will get your answer 1.92 grams. That's all. Okay. Now the next one is, what is limiting reactant? How will you determine it? Limiting reactant, which consumes early How to determine it? You have to calculate the number of moles of product from the given data, find out the number of moles of product with the help of the balanced chemical equation, and then the reactant which produces the least amount of product is calculated as the limiting range, right? Now this question is quite easy, you can answer it well now yourself. That is, define theoretical yield and actual yield. I hope you are familiar with it. Theoretical yield is the quantity of product calculated from a balanced chemical equation, right? That is a theoretical yield. That is also called as the expected one yield or the calculated yield. It will give you the maximum amount of product without any side reaction is being occurred over there, right? And it is always higher or greater than that of the actual. What about the actual yield? Actual yield is taken out after you have performed an experiment or practically the work is done. It is an experimental yield, right? The actual yield of a chemical reaction is always less than the theoretical yield. Why? There can be some mishandling of the apparatus, of the mishandling of the some what to say the processes, procedures you are carrying out. There may be the side reactions. It's all about the that is actual yield is always less than that of the theoretical. Now the next one is what is conversion factor. I hope you understand it well now that the conversion factor is the ratio of coefficients found in a balanced chemical equation which can be used to determine the amounts of any two participants is called the conversion factor. This is the same as it is given in your book. The formula used is conversion factor is equal to unit to determine what you want, the quantity of the substance you require that is written as a numerator, and the quantity which is given from which you have to prepare the other that will be given as a denominator. Now here it is given by means of this reaction that 1 mole of this is propane. When it is undergoes combustion, it produces 3 moles of carbon dioxide and 4 moles of water. Now the question is that you want to determine the number of moles of carbon dioxide from the given moles of C3H8. So from this balanced chemical equation you will say 1 mole of C3H8 is going to produce 3 moles of carbon dioxide. You have to calculate the further the carbon dioxide if the quantity of C3H8 is given. So the conversion factor will be 3 upon 1. Right? Now again here a very simple question. What is the relationship between mass and volume of the gas? I think these are the questions you can take it out from the book yourself. Right? For your ease, once again here 44 grams of carbon dioxide is equal to 1 mole of carbon dioxide is equal to 6.0 tons per 23 molecules is equal to 22.414. Right? It's quite simple. Right? And if we say for the half of the mole of carbon dioxide, what will we say? The mass will be half, right? Half. So the number of molecules in it will be moles multiplied by molar mass, right? And the volume it will carry, that is for 44 grams is mole 22.414. The 22 grams is mole how much? 22.414 divided by 44 multiplied by 20 will become half of it, right? And further half will give you the further half in the what you say the volume of the gas. So you have to remember it that gases according to Gay-Lussac's law, if you remember, the gases they react in the equal what you say the whole number ratios they react, right? And the value is 22.414 dm³ for each mole of the gas at test. The next one, last questions are there. What are the representative particles in 1 mole of gas at STP? Very, very simple. What the representative particles? Representative particles equals equal to that is the Avogadro's number of particles, is it? Which contains how much? 6.0 trans per 22 particles. Now correlate all the parameters which you have learned in it. 1 mole of hydrogen, mass is 2 grams, 22.414 dm³ is the volume, and number of particles in it are 6.0 times per 23. Now whereas we are dealing with the molecule, so the term molecule is applied. Similarly, for 1 mole of methane, the mass of methane is 16 grams, carry volume Again, 22.414 equal to 6.25. And the last one is how to define stoichiometry and stoichiometric amounts. The quantitative relation between that or the amount of reactant and product is termed as stoichiometry given by a balanced chemical equation. And what the amounts are there when you correlate from the balanced chemical equation, that how many moles are present on the reactant side and how many on the product side. When you correlate with these two parameters, you say these are the stoichiometric amounts. Right? Now all the MCQs and short question answers are done. Read them carefully and try to find out the answer. If you get any problem, you can ask me. And read the other long questions as well. Try to find the answers in your book. If you have any problems, you can ask me again. Numericals we will do later. Inshallah.